very quick. I will start by a practical view of what SoftAWERE is and what we are working on right now. So when you look at using SoftAWERE, what you will have today is a GitLab group that you have to join, where you can create projects, hopefully software projects that you want to evaluate. Thanks to that GitLab group, you will be attached to a GitLab runner, which is a machine dedicated to running the CI jobs. So you will be able to run multiple CI jobs to try your software. We'll look a bit deeper in the ways we try and test the software. And for each job, what you will get in the end is something like that. Many metrics. We'll dig a bit deeper in that. And in the end, you will get some results. So if we have a quick look, we will see stuff like global warming potential. So it may ring a bell and you may associate that to CO2 equivalent emissions. We see that this metric is composed of operational emissions on one side and embedded emissions on the other side. We will zoom in that and explain what is operational and embedded. But keep in mind that one of the purposes of this project is to also include, I could zoom, of course. So message, maybe it's better like that. What we try to do is to include in the evaluation not only the impacts of the usage phase of a software, but also the impacts of the hardware that is necessarily attached to the software. As Max said, no hardware, no software running. And so, as an introduction, embedded emissions or embodied emissions are what it's about. We have other metrics like abiotic resources depletion, primary energy consumption. To explain it very quick, we try to have a multi-criteria approach. So not just focus on CO2 emissions, because the impacts of ICT are not just about CO2 emissions, unfortunately. And so when you have that in the end of your job, that's a bit rough to have just those results. So we also work on monitoring dashboards that you can get access to, where you will have multiple things. The first part of the dashboard so far is about the impacts of the host itself, so the GitLab runner itself. So we'll have metrics about energy consumption measured by software. So this comes from REPL, so the interface that has been mentioned just before. We also have energy consumption from APMI cards collectors. This is great because we can make comparisons. On the top, we have, let's say, the whole impact of the host, including, of course, carbon emissions, but also, as we said before, abiotic resources depletion, primary energy consumed. And then when we go down, we have impacts per job, per continuous integration job that we launched. So we'll have the IT resources consumed by the job, and then the evaluation of the impacts, splitting operational and embodied impacts. And the idea is, of course, to be able to dig deeper in how the application behaves and how we could possibly reduce its impact. So I'll just finish with a few slides. This is not really interesting. I'm Benoit Petit, we can talk later. I come from Boavizta, so this is a French nonprofit working closely with the SDIA to provide open source tooling methodologies and data to help with assessing the impacts of ICT on the environment. The demo has just been done. And just to explain why I was talking about both embodied impacts, operational impacts, we try to base our work on a methodology that's lifecycle assessment that's defined in the ISO standards that you see on the screen. And this approach is interesting for mainly two reasons. The first one is that it takes into account the full life cycle of a product or a service, an ICT service, including raw materials extraction for the hardware, manufacturing, distribution, transport, installation, the usage phase, which is what we base many, let's say, most of the time when we talk about the impacts of ICT, we talk about this phase, and we base our work on this methodology to not forget the rest. And in many cases, the other phases of the life cycle represent the bigger impact. So it's very important to know about it. And the last step might be the end of life of the hardware and of the service, and eventually the recycling. Another aspect why it's important is that it's multi-criteria. So we can take into account multiple impacts and not just CO2 emissions. This is a quick correlation between the life cycle assessment methodology and the GHG protocol, which is maybe the standard the most used to account for GHG greenhouse gas emissions. So what you have to keep in mind is just that when we talk about usage in GHG protocol, it's scope 2, it's called scope 2. And when we talk about all the other steps of the life cycle, it's scope 3 in the GHG protocol. And in our project, to make the connection, when we talk about scope 3, so extraction, manufacturing, transport, end of life, it's embodied impacts. And when we talk about usage, it's operational impacts. Regarding the criteria of impacts, as I said, we don't measure only CO2. There is, of course, global warming potential, CO2 emissions, CO2 equivalent. We said primary energy use, abiotic resources depletion, but you can see that we could measure other criteria of impact, and there are many more than just the 6 on the screen. And this slide, the purpose of this slide to show that the road is still long, to have a full grasp on the impacts of ICT, especially when we try to measure something very precise like the impact of a software. A quick overview of the architecture of the project. How does it work behind the scene? So what you saw is Grafana for showing the metrics in the dashboard in the end of the demo. I didn't put on this slide Gitlab, but imagine Gitlab is there. And we have the CI job that I showed you, which is there, which has a short lifetime. And in this CI job, we just have a simple script that will call for metrics. And the interesting part is where those metrics come from. So you see many names here. So there is Boagent, there is Boavizta API, there is Scafandre, there is Push Gateway. So maybe you may know that Push Gateway in Prometheus, it's just monitoring tooling. It's a time series database that you can store metrics in. The Push Gateway is just another way to send the metrics to the database. And about the environmental parts, everything happens there. Oops, sorry. So Boagent is about, let's say it's a framework, so it will do many things. It will scan for hardware specifications of the machine. It will call for power consumption metrics, and in our case today, it will call for data that Scafandre generates, which is power measurements on the machines and power measurements on the processes running on the machine. And on the other side, it will call for impact factors from a project that's called the Boavizta API. And that also does many conversions, very useful to have the numbers you have seen before. We are working on a public documentation to allow as many people as possible to try the project. So the link is there, but you will have it afterwards and in the workshop if you are there. We are also running on one part of the documentation, which is how to install your own software at home in your own machines. So this is work in progress, but we could have something working in the next weeks, very shortly. And just to explain, but I will go very quick because I guess I'm over time, about the Boavizta API, which is maybe one of the most important components. It's an API, so you ask to it a question like, what's the impact of my machine when my machine is composed of this CPU, this memory, and so on. You could also ask more complex questions like, what's the impact of an AWS EC2 instance, and how we are able to answer about the impacts is we have based our work on methodologies we found in papers from Fraunhofer, from Oko Institute, and other great laboratories. And the base of our methodologies, we have the impact of one semiconductor, let's say. More precisely, it's based on the impact of a die, which is the little square of silicium you have on wafers, and wafers are slices of metal bars we use to manufacture semiconductors. And so it's really about bottom-up calculations based on the impact of very tiny bits of the components you have in a machine. Scaphandre is the tool we've seen on the drawing about measuring energy consumption. And we will discuss about it in more details during the workshop if you want. And BoAgent is the framework that's on top of those two projects, Boavizta API, Scaphandre, and what he will do in addition to that is scanning for the components of the machine so that we know what questions we have to ask to the Boavizta API. So I think I will stop there. Should be enough.
Thank you, Benoit. I think we'll go back into the physical